Okay, let's start with London equation. This is a first approach to explain of the superconductivity of the material. Up to that point, we already know about this. What is superconductivity? This is another state, and we tell about different property of the electrical and thermal property. We know about the specific heat, internal energy, energy gap within the superconductor. What is the difference between superconducting and the normal state for the different property, thermal conductivity, isotopic effect, etc., etc. Now we want to know about the explanation of the superconductivity in terms of electronic state or vibrational state, etc. In Norden equation, we tell about the electronic state and we calculate the two London equation, and then we find out the perturbation depth of the current, and this equation also explains some part of the superconductivity but totally does not explain by this London equation. The BCS theory explain the total part of the superconductivity. This will in be the next part. In this video, want to derive or know about the London equation, right? Okay. So the London equation. Okay. In 1935, in 1911, Ons develop or first experimentally obtain the superconducting material of the Hg below the 4.2 Kelvin temperature. In 1935, in 1935, London Brothers, that is F London and the H London, two London brothers are want to explain the superconducting material or the superconducting state. At that moment, there was only Maxwell equation. By the Maxwell equation, they cannot explain the, they cannot uh, satisfy the phenomena of superconductivity. So at that moment, they cannot explain. That's why the Maxwell equation, Maxwell at that moment, the Maxwell modified by London and they give to London equation. London to London equation. To London equation. Okay. Set gives to London equation. According to this, their theory, London equation, according to their theory, according to their theory that there are two types of electron which already discussed in the previous one, that is normal electron and the normal electron and the super electron, which already discussed in the previous one, super electron, right? They takes as the two types of electron exist within the superconductor, right? Now consider a superconductor. This is a superconductor. Within that there is a electrons. There is some electron like that within the superconductor, right? Take Ns is the number density of super electron within the superconductor. Number density of super electron within superconductor, superconductor. Okay. So what will be the force if we apply a battery of the two end of this conductor? If we apply a battery, of two end of this conductor, just apply a battery of two ends of this conductor. So what happened? Very bad. So what happened? The force on the electron, force on the electron will be F equals to minus charge into electric field, simply. So the equation of motion will be mass into acceleration. Acceleration is nothing but m into dvs, s for super electron, velocity of super electron. Clear? So from here you can say that dvs by dt, which is nothing but minus e by m, capital E. Okay. Now I want to find out the current density of super electron. J is the current density of the super electron. That is nothing but the minus ns vs E. You know the current density. Ns is the density of the super electron. Vs is the velocity of super electron. E is the electronic charge. So what is the value of J ds by dt? This is nothing but minus ns is constant, E is constant, just dvs by dt. Okay. So if you put here ds by dt, that is djs by djs by, very problematic, djs by dt into minus 1 by e, which comes here, you will get e square ns by m e. Okay. This is nothing but the London first equation. Oh, this is the London first equation. London first equation. Okay. So just think about the explanation of the superconductivity from the London's first equation. That is the dgs by dt equals to, oh, that is the e square ns by m into e. E is the electric field, right? So So dJs by dt is nothing but E square ns by m into E, right? So if electric field is zero, so there is no battery. If E is zero, there is no battery, then dJs by dt will be zero. So from here you can say Js will be constant. That is without any electric field, that's mean without any battery, there is a constant current flow within the material, which is the property of a superconductor, right? So you can say this London equation explain the property, one of the property of the superconductor, that is the current flow within the superconductor continuous without any external battery source, which is the first we say. In case of normal, normal metal, you know, in case of normal metal, you know that J is sigma E. If E equals to 0, if E equals to 0, what happen? J also 0. But in case of superconductor, the J is not 0. This is constant. Clear? From this first equation, we can derive the second equation of the London. How? Just put from the first equation, you can see E is nothing but, oh, this is very problematic, m by E square ns dJs by dt. This is the E, electric field. From the Maxwell third equation, from Maxwell third equation, লেখাটা বড় সমস্যা হয়ে যাচ্ছে তোরে, curl of E is nothing but minus del V del T. This is the Maxwell third equation. If you curl of this, just so m by E square ns, these are the constant taken out, curl of dJs by dt, that is nothing but minus del V del T. So if we integrate this, just integrate these two, so the derivative and these are cancel out, only curl of this is E square ns, curl of j is the left hand side and the right hand side there is minus b minus b0, if the limit will be b0 to b. This is b0 at 0 time and this is b for t time. Okay. So in case of superconductor, you know the Meissner effect. Meissner effect says there is no magnetic field within the superconductor. It's like behaves like a dielectric material. B naught is the magnetization or the magnetic field within inbuilt the material. But Meissner effect says that this B0 will be 0. Meissner effect says that this B0 will be 0. Meissner effect says that this B0 will be 0. Meissner effect says that this B0 will be 0. Meissner effect. Meissner effect says that, oh, B0 will be 0. B0 is nothing but this will be 0. The Meissner effect says that the B0 will be 0. Okay. So you can see the relation like that, m by n square, no, E square ns. E square ns curl of js equal to minus b, right? So you can say curl of j কি হচ্ছে, curl of j is nothing but minus E square by ns by m into b vector. Okay, this is nothing but the second London equation. This is the second London equation. These two are equation given by the London's mother. Okay. From this equation, we can derive another property that is known as the penetration depth. If you just curl in the both side, curl of this, curl of J S, S, this is S, S for super electron minus E n square, no, E square ns, E square ns, this is the E square ns by m, E square ns by m, E square ns by m, this is E square ns by m, this is set into B. So this will be curl of B. This is the curl of B. Curl of B, you know from the Maxwell fourth equation, this is the mu naught J plus epsilon naught del E del T. At E equals to 0, that is no electric field for E equals to 0, this will become, this is gives you two terms, that is the divert, you know the property, identity property of this is nothing but divergence of J and minus get square Js, this is also Js. This is the first part, and the right hand side, this will gives you curl of mu equal to mu naught J, that is minus square minus E square ns by m into curl of B is mu naught J, and another term will be 0, that is the epsilon naught del E del T term will be 0 in that case, right? So this is grad square J S, this term is 0, so you will get this, so this is nothing but grad square Js, and this is 1 by lambda L square, and this is the Js. So lambda L is nothing but the penetration depth, penetration penetration depth, which is root under m by ns square mu naught. This is the penetration depth. This is the penetration depth. This is if we penetration depth, that is Js with respect to x. This is like that. So Jx can be written as, this is the Js at point x can be written as Js 0 e to the power minus x by lambda L. Okay. And Bx, similarly you can say the magnetic field also when it trade decay like that, lambda L. Okay. And another property also get from this relation, that is curl of Js, that is minus n square n s square by m curl of A. B vector can be written as this. So if you can say Js is nothing but minus ns square by m into a vector. So from London equation, you get some property of superconductor. There is no problem, but total explanation not happen by this London equation. Okay, there is lot of problem regarding audio or the writing skill. If there is any problem, you must know about me in the WhatsApp. If there is any problem in the next part, I want to cover the BCS theory and the next one. Okay, that's it. If they are in problem,